Hi there, and welcome to another episode of Harrison Hobbies. Today we are going to continue our video that was made many months ago, probably close to a year ago now, where we built a 120 volt AC adapter that would put out 1200 watts, and it would put that into a Milwaukee 18 volt battery. We tried it, and again, online, some of my viewers have commented that they built something similar. They got the 18 volt table saw and it wasn't able to power that. And we sent this off to the torque test channel. So big thanks to those guys for trying this out. And they tried it. It had, we'll say, some nuances to it. And I was challenged by them to come back with a larger, more powerful system. So I guess the game plan here is this is going to comprise of maybe 3 videos, probably a bit of a series here because there are some goals that I want to get to. So the first is ultimately, I want to be able to power the table saw. I've got the M18 chainsaw. We can try powering that. We've got some other tools here so we can really push the system to the limit. But there were some other, I guess, questions, such as would capacitors work? So on this one, I found some smaller capacitors that were similar to like an 18650 in size, but in terms of capacity, we're talking, milliamp hours, fractions of a milliamp hour. So we've got some bigger ones here that are 18 by 35 millimeter, 50 volt. So these are a little bit bigger than the ones that we had in here. We can try those. I think there was a video that I'd put out, like kind of reacting to the torque test channel and talking about next steps. So I guess since I'd recorded that video 6 months or a year ago, there's been more time to think about how to handle this. So we've gotten more stuff here that wasn't even in that video. So we can look and see whether or not the battery pack is going to be influenced by these. Additionally, I've heard that these power supplies, I've never hooked these up to an oscilloscope, and so there's the theory that these aren't actually giving a smooth power. They're jolting, similar to how a battery charger works, right? Where it charges up a capacitor and then dumps the voltage. Charges capacitor, dumps, charges and dumps. So they're expecting some kind of sine wave or at least some pulse wave on these. So because we have our second one that in theory is identical, it's another 1200 watt with the exact same similar bent tab. We'll be able to use both of these in parallel to, in theory, give ourselves 2400 watts. Putting these two in series, we want to make sure that we're not getting into some weird, charge thing where they're going to feed each other. Whenever one goes high, the other one's off, and then suddenly they're trying to force power into each other. We've got some transformers here. I guess this is a step-up, a boost converter. These are not giving the 24 volt max, right? That one of these battery packs, in theory, fully charged can be. And so we're seeing some sag there. Lastly, there was a lot of talk about how the little connectors that we had on here, I think the XT60s, weren't nearly enough. So I figured that we can try some XT60s. We've got a load tester here. So we'll be able to hook this up to probably just a regular battery, just so we have consistent power. And then run this at max and see what happens to those heaters, not heaters, see what happens to those terminals. And so we've got, the FLIR thermal camera here, new updated one for that. And then we'll try it again, like I said, with the XT60s, and then we'll move to the XT100s and we'll get a thermal profile of that. The wires, we can try a different gauge of wire and see the impact there. And then measure any kind of voltage sag that we get from those constraints. And then we also, like I said, we had the table saw, so we'll try that with just one of these inverters, like the as-built here, and try if we can replicate what some of the viewers have been observing. As I noted on earlier, this is probably going to be a 3-video series. I don't think that anyone would want to watch me talk for a couple of hours straight. According to my viewer metrics, on average, I think you guys watch me talk for around 5 minutes. So we'll try to break this up into some bite-sized chunks here, and then that will also help me to post, because again, I will certainly not be getting through all of this tonight. For our first setup here, over in this corner here, we've got our GoPro. It is going to be looking at an ammeter. We have this little adapter here that is going into the positive and the negative battery. The rest of these on the battery are handshake terminals. So we've got our positive and negative. This is going into our amp meter here, which is going to tell us the voltage. We can check out voltage sag, all of that. And then this is going through the cable, and then it will end up in our Milwaukee battery pack here. So this is going to be the first setup. So we've got some 1x4s here. We're just going to be ripping these. These are what, maybe 2 feet long. So we'll do a couple of cuts on these boards here under just the 12 amp hour battery from Milwaukee. And then we'll do another couple and see what kind of beans we can get out of it, to use the Torque Test Channel's term, with our power supply here. And then this will kind of be the, I guess, the precursor to all of the other efforts that we're going to be undergoing. So let's get in. So we're going to have this larger one here is coupled to the to our black cable here. So this is going to be measuring the current. We've got the GoPro here looking at both of these. We have the smaller one here, red and black terminals coming positive and negative, and they're co-mingled with the leads on our 12 amp hour battery. So this is going to be our new test setup. So we'll be able to look at actual wattage draw based on our voltage and our current that we're pulling. Okay, so I was keeping an eye on that right there. We're somewhere in the neighborhood of 1,000 watts on this, which would make sense. We will now uncouple this from the battery, and we will look at our power supply here. And I'm not done with the cabinetry in my kitchen yet. We still have some wood over here, so I'm really hoping we don't burn this out and I have to go back to my Ryobi saw. Okay, so I'm sure you hear the buzz here. Now we have our power supply here. We're running the same. For some reason, my current is showing a little bit above, so I'm not sure if I left an offset off. We're just going to let it be. I didn't realize that until right now. So if you're looking at this, and I'm probably going to have the current up here in a corner or something showing real time. So just be cognizant of that. This thing right now is dialed in at 19.6 volts. So, and again, that's kind of maxed out. So we tested on the drill here. We're working just fine. And then we can put this in and hope that nothing bad happens. Now, important to note, right, like you can't see that right there, but we have the 4 battery indicators. And with this battery here, this thing was like 95% charged. Doing a whole bunch of the proofs before the actual video, I accidentally dropped it down a little bit. But it was still had all 4 batteries, lighting up. Now it's down to 3, but it had the 4 whenever we were testing initially. This right off the bat only has 3 of the pieces lit up. So let's try it one more time here. Okay, it failed. So maybe we were a little ambitious here in assuming that this thing was going to work right off the bat. Let's grab the potentiometer here real quick and see if we can get any extra oomph out of this. Nope, it's stuck at 19.6 volts. Interesting that the fan is correlated to the voltage. I would have expected it to be its own sub-circuit. But based on what we did right now, this thing won't even kick over. Could it be that the leads are too small? Maybe. Could it be that the wire's too long and we're seeing some voltage drop? Maybe. We can say without any doubt, I guess we now know what the current is that this thing should be drawing nominally from this battery in line with that equipment. And we know that 1200 watts probably isn't really giving 1200 watts that this thing needs to start. That didn't necessarily go as planned. We were expecting to be able to see what kind of power this thing could deliver, right? And, get it running, and then if we can ease a board in to see how that works. Right, this worked with the miter saw. The miter saw has a much smaller motor, I would assume. And so I think they're different enough systems that it didn't work. I've got the camera zoomed in a little bit. I record in 4K. Everybody probably watches this in 1080, so we'll likely be able, if there's anything relevant, zoom in. A couple of pieces to start out with is I did unshell a 6 amp hour. This is another Super China from the same brand as the one we have been using. The one we have been using originally, we had these connectors on here, right? This is an XT60. So we can see a comparison. I've got a baggie of more XT60s, but this is going to be an XT100, XT90, sorry. This is the XT60 connector that everybody lost their mind over that I was using. And then this is going to be an XT100 here. So you can see this one here is quite a bit larger, and the prongs are a little bit larger. But let's talk about how power is actually transmitted. So you see we have all these little these pressure clips in here. So the tool is basically this, right? We have a positive, which I believe is this one, and a negative, which I believe is that one. It really doesn't matter how big those are, because ultimately what's going to happen is, regardless of how big, you still have these tiny little barbs fitting into here. Additionally, the thing that's actually transmitting the power from your batteries, when your batteries are in one of these batteries in series, so you can get to your 24 volts or 18 volts or 20 volt max, whatever it is going to be these really, really thin tabs. And again, I've pulled apart 10 amp hour batteries from Milwaukee, or not, 9 amp hour batteries, as well as a bunch of, the lower voltage ones, trying to get something that would work for this experiment way early on. And they have the exact same pieces of metal, right? I mean, these are not thick, these are not substantial. So whenever people say, oh, you're choking out all your current here. No, not really. No, what's choking out the current are this interface right here, and is going to be the connection between your battery and the actual circuit board here. So to dispel maybe some of this myth, we will try XT60s and XT90s here. And again, we'll apply a load to them. We'll run a thermal camera and see how much they're heating up under the equivalent load. But I've been wrong before. I don't think I'm going to be wrong on this one here. So I guess our intention here will be, we have our original, we know that it works, right? We've got our original power supply here, and we've got the XT60 connector. We're going to solder up an identical output like this from the other adapter here. We are going to put in the same thing here, except it's going to have an XT90. Additionally, we're going to have a Y combiner. So we have our battery today with an XT60 on it. Whenever we solder up this larger battery here, we're going to solder on the XT90 onto this one. The ability to combine both of these, so we'll have an input that's going to be an XT60 and an input that's going to be an XT90, and it will give us one output out that's going to be an XT90. And then we're also going to build a couple of these that are going to have just kind of general probe points, so we can put in, a multimeter to measure the voltage, or we can, inject some other current there, inject some capacitors into there to see if we can kind of level out, depending on what the waveform of these looks like. So there's a ton of stuff to test here, and it'll be really interesting trying to edit this video. But I guess what we'll do is probably just go into time-lapse mode and then get all this stuff soldered up, and we'll listen to some nice, chill, ambient music. As a refresher from last time, a line in, a neutral, and a ground. And then we also have voltage negative, 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 positive, positive, positive. Again, from last time, there was a lot of question. Do I need to have all three of these hooked up? Still haven't opened up one of these. I don't know if this is 3 separate rails or if these are 3 outputs. So in theory, these, 3 can handle all your voltage, or if just one can handle all 1200 watts. But again, I'm not necessarily interested in risking this power supply and burning up one of the rails in here, because then I'd have to do all of this again. So I think the right move on this kind of thing is going to be to just hook up all 3 and then go. So if we learned anything from last time, it was that I remember it being a pain in the butt to use a 10 gauge wire on there. So what we're going to use now is we'll do three 14 gauges, 1 to each terminal, positive, 1 to each terminal, negative. And then from there, we will have those all seam together into the 10 gauge. So we'll make it look exactly like we did last time. Okay, here we are with this. We'll bring our light this way again. And just a quick reminder of what we're looking at here is you're going to have your line in and your neutral, which will be black and white. And then you're going to have your green for your ground right here. So that's going to be this terminal here. And then we have our voltage negative, 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 and positive, positive, positive. So we'll have our 3 blacks and our 3 reds here. And then here, finally, we have a potentiometer. So this, in theory, we turn this to be able to adjust the voltage out. The other one, it was a little bit different form factor, so obviously this is a different revision. But we'll get that closed. Probably want to neck in all 3 here to try to keep our fingers away from touching. And again, it is a little bit sketchy. The torque test channel was right. And then we'll try to get this close up here too to keep everything kind of corralled together. So right now we are getting 17.9 volt. If we look there, so we will grab a little Phillips flathead screwdriver here. You can see that we're at 17, 18. It looks like we're capping out 18.1, 2, 3, 4, 5, 6, 7. This has been many, many turns. Okay, I'm hearing it click, so I think we backed it out all the way. So this one can do 18.9 volts. Well, I think we are going to conclude with our first night of video here. We've got a lot of time lapse to start editing. We've got a lot more pieces to do here. So we've got several key takeaways from tonight. The first was that we now have a second working adapter. We did some current testing on the table saw and saw that we were roughly, I guess we can just do the math here real quick, 55 times 19.5. So that was about 1,072 watts. So granted, that was more or less sustained. We're probably in the neighborhood of 1,000, maybe 1,500. Again, with these things, they probably require at least a little bit of ramp up there. They couldn't handle that initial, right? And if we look at the exact second that you're flipping that switch, it's probably 2,000, 3,000, 4,000 watts there. And so these machines just can't handle it. This will, like I said, be the first of probably a 3 or 4 video series. Again, don't forget to like and subscribe to this channel. It helps get some visibility here. I think the content that we're looking at is going to help the overall Milwaukee community. I know that several people have made these adapters. Lots of people have told me that they've made them long before I did. So if that's you, awesome. Also, the equipment that I'm using, the soldering iron, the adapters, all of the equipment that we're using in this video, I'll make sure I have linked as well. And so if you click on those, I will get a commission through Amazon's partner program. But so that, I guess, helps the channel, helps fund all the stuff that's sitting on this table here. But overall, thanks for watching, and check back soon for the continuation of this video.